Hey, good morning, guys. Just wanted to give you a shot of the view that I have right now while you guys are in algebra, and I'm sitting in my hotel looking out over the beach. Don't you wish you were here too? I'm just kidding. I'm just kidding. I'm actually I'm in Franklin, um, but just want to kind of get started today. Give you guys a lesson on this, and hopefully help you guys out a little bit as we work through some problems. How do you work mathematically with polynomials is our essential question. The lesson essential question is, what does multiplication and factoring have to do with polynomials? We're going to work through all that. The SPI, operate with polynomials and simplify results. Those are the things we're going to deal with in the next little while. First thing I want you to look at, get out your foldable, and this is what it will look like. I want you to have this view. This is the way it's going to work. You're going to have your top foldable. You'll write the essential question, or the question there. How do you multiply a monomial and a trinomial? And then the question, and don't worry because I'm going to be rushing off, but it's going to be on the slides that I showed you before. I just wanted you to see how I want you to actually do your foldable. Alright, so let's get over here to the actual lesson. Alright, here we go. So how do you multiply a monomial and a trinomial? Once you write that question, we're going to work through this and just keep trucking. Alright, first thing, as you look at this problem, the first thing you notice is you have parentheses. So we have a distributive property before we do anything else. Notice, here's the first thing we do. Just distribute. Negative x cubed times 9x to the fourth. There, that's like negative 1 times 9, so it'd be negative 9x. Now remember, when we multiply, we add those exponents, negative 9x to the seventh. Next one, there we go, negative x cubed times negative 2x cubed. You have two negatives, so it's going to be a positive, plus 2x, and you just simply add the exponents to the sixth. And then the last step on this, negative x times 7. So negative, positive, minus 7x cubed. And that's just simply, that's how you work it. And if you notice, it's in standard polynomial form. So we're good to go. There's nothing else I can do to this problem whatsoever. All right, so let's go on now. I'm going to give you time, and if you need to pause it here to copy down, whatever. And then this is the one I want in your foldable. And then we're going to move on. Here's the first practice problem. This one does not have to go in your foldable. This one can be practice, and we'll work through it in just a minute. Go ahead and pause the video and take a couple minutes and work through this and see what you get. All right, here we go. 5n times 3n cubed, well, 5 times 3 is 15. N, there's that 1 there. It's understood that there's a 1 there. So add my exponents, 3 plus 1. So 15n to the fourth. Then 5n times negative n squared. So 5 times negative 1 is going to be minus 5n. You have 2 plus the 1, 3. Then the last thing we'll do here, 5n times 8, you have plus 40n. And if that's what you come up with, then you're just going to keep rolling. If not, then we need to go back through this and re-show this problem. All right, let's keep moving. All right, here we go. Here's another practice problem. So again, we can pause the video for just a minute and let you guys work through it. All right, here this time. The same thing, it's the same thing, all you're doing is backwards. And for me, I always like to just take it and I'll just rewrite it. I'll say 2b and then b plus 11. And it's the same thing now, it's just 2b times b. You have 2b, and that's like a 1. It's like a 1 squared plus 22. And that's all that I can do there. So whether it's written like this or written on this side, it's the same thing. All right, as we keep going. All right, this one. Again, I want you to take a minute, practice this one, and then, of course, you can play this on when everybody's finished. All right, as we keep going, you have 4x times 2x, 4 times 2, 8, then x, add my exponents to the fourth, 4x times negative 7, so I know it's going to be minus 28x, 2 over here, plus the 1, it's going to be cubed, and the last one, 4x times a positive x is going to be plus 4x squared. And again, it just falls right into place and being in standard form. Alright, so let's move on to the next one. Actually, here's what I want you to do. There's 3 problems, so I want Mr. Taylor to go ahead and pause this, and that way they can have some time to work through these 3 problems. And then what I'm going to do here in a minute, I'm just going to write the answer to these so we have time to make sure I get to the next part. And we'll see if everybody's right. And if you get all 3, you're in good shape. If you get 2 of the 3, you're still in pretty good shape. And here are the answers. If you work this one out, you're going to have 7x squared plus 28x. On this one, you have 30m squared plus 3m cubed. And then on the last one, well, let's actually look through this. So negative 8y cubed times 7y squared, you have negative 56y to the 5th, add the exponents, plus 32y to the 4th, plus, again you have a double negative, 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 plus 8y cubed. So again, if you got all 3 of those right, you are in great shape. All right, let's move on to the next problem. Now this one, this needs to go on the second part of your foldable, the second layer down. Is how do you find the greatest common factor of a polynomial? What we're going to do, we're going to take this problem, we're just going to break this problem apart. That's how we're going to find the greatest common factors. So let's take it and let's break it apart. We take the 5x cubed. Well, I know when I do that, I'm going to have 5 times x times x times x. That's essentially what this is. So the next one, I've got to break it down all the way down to the prime numbers. Here, so I say, well, 5 times 5. So I'll have 5 times 5 times x times x. And that's how I come up with that one. The next one, I think, okay, I can say 9 times 5, but I can break the 9 on down to 3 times 3, which is 9, times 5x. And what I'm looking for here is just the common factors. So as I look through it, I say, okay, I have one complete set of 5s here, so I know that's a common factor. I know I have one set of x's. So here, I don't have enough x's all the way down here, and I have an extra one here. So my greatest common factor is just going to be 5x. And that's all there is to it, really, just to find your greatest common factor. So take some time, make sure you have that one written down. At any point when you, as I'm going through this, if you have questions, make sure you write them down so on Monday you can ask me or shoot me an email or today's meet. All those are good ways to reach me. All right, let's work through another one here. You've got 3x to the 4th minus 9x squared minus 12. Well, in this case, we're looking and saying, okay, I have 3 times x times x times x times x. Well, then I have the negative 9. Then I have, I have to get to 9, I'm going to throw that, I'll just throw that negative right there. I'll say 3 times 3 times x times x. And then the last one, of course, I have negative 12. I'm looking at the number. I have, 4 times 3. But let's break that 4 down and say, I can say 2 times 2 times, which is 4, 3x. Well, I can look and say, do I have a 3 in all 3 things? And I do. So here, I'm going to circle those because I have one set of 3. So now I have 3. I don't have 2's in all 3, so I can't say that that's a common factor. But I do have one set of x's again. So again, my greatest common factor is going to be 3x. Because here, as I look through this, I only have a 3 in all 3, and I have an x in all 3. All right, again, go ahead and try this one on your own. So you can pause the video, and then I will work it out in just a minute for you. All right, so let's look at it now. I got 12 here, so if you had your thing, you could say, 4 times 3 again, so I could say 2 times 2 times 3 x times x. And here I have 20. That's a little more tricky, so I can say, 5 and 4, right? So I could say 2 times 2, which is 4, times 5. Now, what are my common factors here? If you look at this, my common factors, now this is a little bit different. I have a set of 2's and another set of 2's. And that's all I have. So the greatest common factor here would just be 4. So I would take, because I have common 2 times 2, which is 4. So my greatest common factor is going to be 4. All right, here's another one. And go ahead and try this one on your own, and then we will go through it in just a minute. All right, here we go. I have a times a times a. 6, I have 3 times 2 times a times a. And 11, I just have 11 and times 1 times a. Well, my greatest common factor is just simply going to be a. So here I don't have a 3 in all 3, don't have a 2 or 1, and I don't have any more sets of a's. So here's what I would like you to do. Go ahead and do page 483, 19, and 20. And then Mr. Taylor, they can check with you and see if they got the right answers. And at that point, I'll leave the assignment for you guys to practice. Hope you have a good weekend, and I'll see you on Monday.